think it should go over here.
Yeah, you think.
The microphone and the camera.
Yes. It's like a little soft pad.
It's like inverse, because when I go down, it goes up.
Okay, all right. Worksheet. We have a homework assignment due today. That was your 1.5 part 1. It should be only on sine. A lot of you turned this in the other day. If you have not, that is due today. Now, everyone should have received a 1.5 continued worksheet. 1.5 continued, it says at the top. And if you notice that all the problems down the page have cosine on them. My goal today is to do 1 or 2 examples of tough problems with cosine. Real tough. I will make them up, and we're going to go through them. Now, that will get you hopefully to the point where you can go through the cosine worksheet and get through it all the way. Some of you have already turned it in. That's great. I haven't even done it yet. Okay, now, the goal today, after I'm done with these 2 problems, I'm going to intro tangent, and I'm going to intro cotangent today. Easy problems, and then we're done. My goal is to do 4 problems on the board. That is it. Does everyone understand that? So Vanessa, since you walked in, 1.5 is due today. That was the one on sine. So I don't know if you turned in already. And then, did you receive a 1.5 continued yesterday?
No.
Okay, that was the one with cosine. That was, it's not due. It's the one I was handing out today. It's just I was gonna hand it out.
They all like
So
square
We're doing one that was Monday then, or?
that's something we gotta talk about. Okay. All right, hey, did everyone get one of those 1.5 continued worksheets now? I think everyone did. Okay.
Cosine first, is that what you said?
Cosine, 2 problems. Kind of a medium and a tough difficulty. All right, here we go. Okay. All right. So let's walk through the medium and difficult types of problems for cosine. This is what your worksheet is based on today. That's the worksheet 1.5 continued. Here's the problem with this worksheet. It's due on Tuesday next week. It's due on Tuesday. Some of you have already turned it in. That's great. It's due Tuesday. We're probably looking at an assignment next week, either Monday or Tuesday, and that'll be on tangent and cotangent. And then the next day, probably Wednesday or Tuesday or Wednesday, we'll probably look at an assignment on cosecant and secant. Okay? So I'm trying to stretch this out so it's manageable and that you're not getting flooded with homework. Because previous years, I just turned an assignment out there. It was like 20-something problems, and it was just sine all the way to cosecant, and they're all mixed together, and they're all tough and hard, and it was just too much. And it was it's nice to just focus on one type of problem and get it good. And then focus on one type of problem and get good, instead of being marginal at 20 different problems. So, all right, so cosine. Let's do a medium-based difficulty problem. So let's go with, the function is 3 cosine 5x plus pi. I consider this a medium difficulty problem. It's got a horizontal shift, no vertical shift. Now, which direction am I shifting? Left or right?
Left.
Left, because it's a plus pi. That shifts this thing to the left so many spots. Now, let's talk about the order we need to do this in. We talked about this the other day. We need to figure out the spacing first. This is the order we talked about. You have to figure out the spacing between each of your hash marks. Then what we need to figure out is the actual horizontal shift. So we talked about the horizontal shift. What that is, that's your starting point. Starting point. That's what we have to figure out, like where's that first hash marker at. The next thing we'll focus on is amplitude. Figure out the amplitude, and then we'll figure out if there's any type of vertical shift last. These are the things that I go through when I'm doing every problem to make sure that everyone knows where we're at. Now, the amplitude and vertical shift, they could be...
I do vertical shift first.
Yeah, that's fine. It's these are interchangeable. Really, the tough stuff is the spacing stuff. That's the stuff we're going to struggle with.
Why would you do vertical shift last when all you got to do for vertical shift is write down where it starts?
Yeah, but the problem is that I always do the vertical shift last because I'm always worried about the 4 hash marks. And then when I do the vertical shift, all I have to do is put that number right where that bar is at. So that's all I really care about. It doesn't really require any strenuous work. All right, are we good so far?
I'm gonna read.
All right, so let's talk about the spacing.
You say you're Nick Breezy?
Okay, all right, so spacing. Let's do this part first. Now, again, like I've kind of reviewed with you, I usually do the spacing completely off to the side on my homework. I don't put it on the page itself. So spacing, it normally hits 2 pi. We have to divide by the number in front of my x. Well, the number in front of x is 5. So that means on this particular problem, if I was drawing a normal cosine graph, this would be 2 pi over 5. That'd be the fourth hash marker. That'd be the normal spacing. We don't have that because we've been shifted left to right. But I need to figure out the first hash mark. So I'm going to cut this in half. This is 2 pi over 10. And if you want to simplify that, that's pi over 5. And then I'll cut that in half again. That's 2 pi over 20 or pi over 10. However you want to say it. I don't really care. I'm going to use the pi over 10. But again, it's cut in half, and then multiply by 3 if you need the next marker, but I don't care about that one. Okay, so the spacing here, the reason why I do this off to the side, this is all I need. That is my spacing to the first marker. That's all I care about. I don't care about the other hash marks. I care about the first hash mark. Okay, does that make sense?
Yeah.
All right, now. Okay, so now that we know the spacing, that's going to be pi over 10. I'm going to use that and figure out where my shift is. So spacing is a check. I know what my spacing is. It's pi over 10. The horizontal shifting, the horizontal shift, is now I got to figure out where my starting point is. Set it equal to 0. All right. So. Okay. Okay, all right, good. You're already starting to do it. 5x plus pi equals 0. We start with whatever's in that parenthesis. You set it equal to 0. And this is going to figure out where my starting point is in my graph. Because it's not going to start at 0, 0. So we subtract pi over.
Pi over 10. And then
Yep.
you start at.
And divide.
-1 pi over 5 or
Yeah.
This one was easy.
Okay, yeah.
Because you just add pi
It's a
over-
medium difficulty.
So it's just
the
3 pi over
hardest,
10, 4
why I
pi over
consider
10.
this medium, we are actually shifting it right or left.
Is this hard stuff?
This is medium so far. We haven't done the hard problem yet.
Is
Let's
that
do
just
hard.
like decimal fractions, would you say?
Yeah, like some nasty thing where they throw this wicked fraction that in
Isn't
inside.
it the same thing though? Just
Yeah, it's the same concept, it's just you have to do more work.
Or like
That's
more
like
than
horizontal
Yeah.
shifting without
unless you have a
pi.
smart calculator.
All right.
Not
Okay.
easy work for the rest of that. Okay, hungry.
Is that your starting point then?
Yeah, that's my starting point. Okay, all right. Now that I figured out my starting point, the rest of this should be easy. So here's what I do. And this is just when I draw these pictures, this is just kind of how I do it. I draw my line, I put my starting point here, which was the negative pi over 5. And then I'm going to spread 4 hash marks after it. I don't care about the vertical, like y-axis. I don't even care about it. I know that this thing's been shifted up and down 0. So really, if you think about this, I only have to worry about where the amplitude goes from that number, because I didn't really shift this thing up or down. My amplitude number is 3 and negative 3. So this spot is negative pi over 5, and the origin line is right here. This is actually the x-axis. And so now 4 hash marks after it, here's how you do it. You just take the first hash mark and you add what your spacing is. So this is pi over 10. That's that first hash marker. I'm adding the pi over 10 as my spacing over. Okay.
Can't you actually add that together?
Yeah, you can actually add that together because you'd have to actually get this as a 10. So this would be negative 2 pi over 10 plus pi over 10, and this ends up being just negative pi over 10. So it's getting closer to 0, 0. And then I add another pi over 10,
0.
which would be 0, because you add pi over 10 to that thing.
It's negative, I forgot.
And then I add another pi over 10, which would be pi over 10.
Pi over 5.
And then I add another pi over 10, which is 3 pi over 10.
Why didn't I say pi over 5?
No, 2 pi over 10, wouldn't it? 2 pi over 10.
Pi over
Yeah,
5.
it's a pi
Yeah.
over 5.
Pi over 5, thank you.
I was gonna say, just typed it.
Okay, so Does everyone understand how I get my hash marks?
Yep.
I showed the first one because I showed that you can actually add those two together. You have to get common denominators and actually add, and it did actually add up, so it made negative pi over 10. And now I can actually draw this thing. It's a cosine graph. It's going its normal direction. I don't have a negative out front. So this will be, it'll start up here, it'll go to 0, go to its lowest point, come back to 0, and come to its highest point. So it just looks like this. Now, if you were to compare this to the original drawing, it's a shift. It's literally 5 of these pictures in the normal 1 picture of cosine, and it's 3 times taller in terms of wavelength. So,
What did
all right.
Why did I do that?
Okay, questions at all about what we've done up to this point?
Why did I do that?
Man, it's gonna be kind of sad when I have to get a permanent 2 too.
A what?
A permanent 2?
Hey, are we good?
Wait. Yeah. You stupid.
I woke
All right,
up.
I'm gonna leave that on the board for a little bit.
Hey, what is it?
Hopefully that made sense how I went through every problem. I didn't lose anybody at any point, did I? Okay, let's get, okay, now, hey, here's my question. Maybe I can save my time. Does anyone need to see a difficult looking problem with this, or do you think you can handle the stuff that I've showed you?
I think that. You just go through it super fast. Like.
Okay.
Don't stop, just like do it.
All right, I'm gonna just do a problem how I would normally see it. Okay, I'll let you guys pick the numbers and fractions and stuff. Okay,
1/5.
Negative cos parentheses x over 2 minus pi over 2 parentheses negative 5. Oh, this is easy though. Is this actually hard? No, this is really easy.
is this one of your, oh, is this one of your problems? So I'm gonna change this to, I'm gonna change this to 2 pi over 3, and this is an 8, yeah, all right. Okay, all right. Oh, all right, here we go. Clever. All right. Clever, you almost had me.
That's close.
It was close.
Change 1 over 5.
Ow. All right, you ready to go? Okay, I'm gonna do this really fast. I'm gonna show you what you should be able to do, how you're supposed to handle this. Spacing. 2 pi divided by 1/2, because that's the number in front of back. So you multiply that, you flip it, multiply it, it's 4 pi. So that means the 4th hash marker would be 4 pi, cut it in half, so that's 2 pi and pi. So my spacing is pi.
Whoa.
Now, so that is your spacing. Now,
Oh, that's easy.
so now, the starting point, I'm gonna set this thing equal to 0.
Oh, that makes sense.
Okay, I'm gonna add the 2 pi over 3 across. 2 pi over 3. I'm gonna multiply the 2 across, so I get 4 pi over 3. All right, so I'm gonna stop
When did
here.
you go into Mach 3 on this?
They told me not to stop.
Why do you
I'm telling
have
you to
three?
stop.
There is the 3rd marker right there. I don't
Stop,
need it.
keep going. Let's go.
I just cut it in half, cut it in half. That was the 1st marker.
Okay.
Because normally you have 4 markers. I found the 4th marker. I cut it in half, and that's the 1st one. And if I want to find the 3rd marker, I just have to take that one times 3.
You show me the simple algebra 1 to get to that.
Okay. And we get the starting point is set equal to 0, solved, boom, there it is. And now drawing this thing. I'm shifting it down 8.
Hold on, I would have probably screwed up. How did you get to 4 pi over 3?
Yeah, I don't get that.
Solve that. Add the 2 pi 3 over to the 0 and multiply by 2. Because you have to get rid of the 2 off the bottom.
Oh, okay, yeah.
Sure. So it's
So this starting point
pi.
right here is 4 pi over 3. That's that point. I have 4 hash marks going this way. The wavelength is going up 1/5 and down 1/5. So this is 7 and 4/5 negative, and this is negative 8 and 1/5.
That's gross.
It's going up and down.
You're only adding pi, so it's 5 pi over 3, 6 pi over 3, 7 pi over 3.
So I'm going to add a pi. Okay, so you have to, if I add a pi to this, this is over 3, I'm going to add a pi to that. So if I add a pi for the first spacing, I have to get a common denominator. It's 3 over 3, right? Because it's 1 over 1. So this is 3 over 3 for common denominator. So it's actually 7 pi over 3.
Oh.
That's how you add like terms. You have to get the common denominator on that. That's adding the pi as your spacing. It was 3 over 3. Add it again, I get 10 pi over 3.
I don't do it.
Add it another time again, I get 13 pi over 3. Because all I'm doing is adding a pi again, and that's 3 over 3. Right? That's 1 pi. It's 3 over 3 pi. Add it again, I get 16 pi over 3.
You said this is 0.
That's the shortcuts that I do in my head as I'm going through a problem.
What page you on, man?
And now cosine. Since it's negative, I'm going to start at the lowest point, go to 0, go to the highest point, go to 0, go to the lowest point. And here you go.
Yeah, that wasn't bad. Not much. Was that actually stored?
May I use a question before we start?
Yes.
Dude, I didn't read books that are interesting. I've read one book and there's Brett Favre books.
Okay, can we focus here real quick? We need to get going here.
So say for instance, pi was your spacing and pi was your starting point. When you go pi, 2 pi, 3 pi, 4 pi, 5 pi. Okay, cool.
Why was that even a question?
Oh, that's the answer to number 5.
All right. Can we move on?
Yeah.
Okay. All right. So now the next thing we're going to do, we're going to introduce tangent and cotangent. I'm going to do one problem of each.
Oh,
It's just going to show you the intro. I'm not going to show you with any crazy numbers. It's just show you the original picture, and then we're going to talk about it on Monday and Tuesday how to manipulate
Oh, we
it.
have the same thing.
Okay?
Very much.
All right. Here we go. All right. Here we go. We're going to intro tangent for the first time. Now, before we get started, I'm not going to put any crazy numbers on this one. I'm going to show you the original tangent graph. Okay, it still follows all those same rules that we've been following, but for mine, I'm just going to do the original tangent graph today to show you how it works. This is just a review from last year, tangent of x. Okay, we're just going to do the original one with a 1 for an amplitude, 1 for a period. We're not shifting it right or left, so that's a 0, and we're not shifting it up or down, that's also a 0. We're just going to do the original picture for tangent, and then on Monday we're going to throw in numbers and start manipulating and see how this works. This one is not easy because all the rules when we get to tangent and cotangent go out the window. All the rules. So yeah, so they kind of go out the window. Tangent and cotangent. It's normal period length. It's frequency. Period. The frequency length is just 1 pi. It's not 2 pi. That is different than for sine and cosine. Sine and cosine go up to 2 pi. Tangent doesn't.
Why would they change that?
It's based on when the answers start repeating on a calculator. So pi is 180 degrees.
Yeah.
So as you go from 0 up to like 180, the answers will start to repeat after 180. So for sine and cosine, they repeat after 360. You get completely different answers.
Oh.
So. Cool. All right, now let's talk about tangent and how to draw it. Now tangent's the goofiest one we have. It is centered over the origin. It's not just to the right side. So it actually has the x-axis and y-axis in clear view, where they're actually the center. Now, you have to imagine that the middle is your origin 0, 0. You're going to have 2 hash marks going this way and 2 hash marks going this way. So there's actually a total of 5 hash marks, because the middle is also considered a hash mark.
That's the starting point.
It's not quite the starting point. I think of it as the starting point. The middle, you're going to go 2 to the right, 2 to the left of it. Okay, now on the outsides, you're going to have asymptotes. Tangent cannot cross these boundaries because y can't cross that. You'd be dividing by 0 on tangent, so you can't do that. So we're going to have on the outsides, the 4th markers, the two on the far outsides will have asymptotes. Again, I'm going to write down that word. We're going to talk about it more on Monday why that doesn't work. Asymptotes.
It's a hard word to spell.
Asymptotes. Okay. All right. Now, the actual numbers. So let's talk about the hash marks. Normally, the up and down distance is not affected. So the amplitude is 1 and -1. So that's pretty easy, right? It's just like sine cosine. We're just going to 1 and -1. Thanks, Miss Smith. And then the 4 hash marks. So normally on tangent or on sine cosine they go out to 2 pi. Well, we're going out to 1 pi, but it's not 1 pi that direction. It's a total spacing of 1 pi. And that's the part that everyone gets thrown off by. The entire spacing is pi, from the left all the way to the right side. So that means you have to split half of it over here and half of it over here. So half of this will go here. It'll be pi over 2. That's half the distance. And then half the distance this way is also pi over 2, but it's just negative. You're just splitting it in half, half and half. So it makes a total of pi. Does that make sense?
Yeah.
Now,
Now you cut that in half.
because now we have to cut that number in half again.
Pi, not 2 pi.
Pi over 4. That was just a number you had to know. It's a default period length. And then, so pi over 4, so that's that number cut in half. And then this side would be negative pi over 4. Because it's half the distance. And now tangent will start in the upper right corner, because it's in like an odd-based function. It'll start in the upper right corner and continue its way down to the left corner. So it's going to start up here. It's going to hit the first marker at its amplitude. It'll hit 0, 0, hit the next marker at its amplitude, and then off to negative infinity. And it will hug right up against the asymptotes. So it'll look like this. And
Ward, will you explain this to me when we're at free time?
Free time.
I just have.
Could there be a linear tangent?
no, it's got a little curve and it's got a curve. If you zoom in far enough in a calculator, it looks like a straight line. But it's not. When you zoom out, you'll start to see like the flowing curve. Because it's still based on circles. That's what it's still based
Pi
on.
over R.
What?
Is it 2?
Pi over 2.
You see the
Pi over
But it's
R.
with the line.
Oh.
I knew exactly what you were talking about there.
It's like pi over.
Okay.
The coffee's.
Pi over the radius
tangent is
of...
starting to the left and then go to the right. Well,
What was that?
if it was a negative tangent.
Yeah, it would just the graph and flip over. Left to bottom right.
Top
Is
left.
that one?
Yeah.
Oh.
What?
Is that
That's why I said-
4 in 1?
Oh.
For the dot over there.
Oh, right here? Or
On
here?
the upper right.
That? Oh, yeah. Pi over 4, that's 1.
Okay.
And then at negative pi over 4, that's negative 1.
No.
Okay, we have cotangent next. This is my last example of the day. Okay, see ya.
It's like, yep, I really am. Are you going to the
It's Garrett's.
All right, last one. Last
for
problem.
you though, so we got
Cotangent. All right, cotangent. It's formula. Here you go.
Wait, how do you make those? Oh, that's definitely not how you make this.
A cotangent bx plus d plus c. Now we're only going to do the original picture, and again, just like before, these go out the window. They're completely different every single time. The period length on this one is just 1 pi, just like tangents. It's 1 pi. Now we're going to just do the normal cotangent graph. So this is the graph I'm going to draw here in a second. I'm going to just draw cotangent of x. That means your amplitude's 1 and your period length's 1. I'm not going to be affecting any weird numbers on this one because we got to see what the original one looks like first.
It's still the box.
No, it's not. So that's the weird thing. It's like tangents like that. And most people think like, well, cotangent would just be like the flip of it because that's what sine and cosine. But it has one thing with sine and cosine in common. Sine and cosine were horizontal shifts of each other. They're shifts, right and left shifts. So that's the same with tangent. Tangent, what they did is they took this picture and shifted it 90 degrees that way. Just like what sine and cosine did. Sine and cosine literally took the graph and shifted it 90 degrees. So the cosine picture will actually be on the right side because this is exactly 90 degrees. Pi over 2 is 90 degrees. So the picture you're going to draw for cotangent is this.
I'm a blind man in a silent movie right now.
Extra T or is it toes?
No idea what's going on. Toes.
Just sitting there in darkness.
Asymptotes.
All right, so we're on the right side of the graph again because it was tangent's graph shifted to the right and then also kind of flipped a little bit. Now it's going to go up 1 and down -1 because that's amplitude again. On the far outsides of your graph, the farthest hash marks from each other, you still have asymptotes. So the asymptote will still be on the far edge and the far edge. So it'll be right on your starting point, what everyone thinks is the starting point. Again, these are the asymptotes. Totes.
Oh God.
Yeah, I was gonna say you erased it earlier. I couldn't see if you said toads.
Yeah, totes.
Toes, asymptotes, asymptotes.
Jane probably heard you from the other class.
Now, the hash marks. Well, what is the full period length?
Half pi.
It's the normal full length is pi, right? That's the full length. Well, we started at 0. If you added pi going this direction, the full length of it, this would be pi. That's the full length. You went out to pi. It's not separated half and half because we're just on the right side of the bar of 0, 0. So it went out a full distance, one full cycle. It's not half and half. It's out full pi. We cut that in half. Then we cut it in half again. And then we multiplied that one by 3. So it's kind of the same work that you did with sine and cosine, it's just you're not going up to 2 pi anymore. Because it's the full length is pi. All right, and the last part here. The last part, tangent. It will hit the middle at 0. So just like it did on tangent, tangent went right through the origin. This is going to go right through that middle dot. On the left side though, instead of being down here, it's going to be up here. It's a perfect mirror image of tangent. So tangent started up here, went this way. Cotangent goes the opposite direction.
God dang it, I just drew the wrong one.
It looks like that. Where it hits its amplitude markers, it would hit the amplitude at the markers around the center.
And they don't like go past the asymptotes either.
But it will never go past the asymptotes. It'll hug up right
It's got a half-life. It's got a half-life. It's getting closer and closer. I'm waiting for the day for you to have a tangent on the left side of your board and a parabola on the right. Or is that a hyperbola? Which one is the bowl?
parabola.
Parabola. And then it will be like that by Luke Brown. Luke really drew that?
Mine to the left is
pretty
really
good.
great.
Yeah, it's pretty solid.
Instead of paying attention, he did that.
Yes. Well, the thing is, he's like, Ward, I took notes. It's just right here.
It's just
You took an hour and you missed about 5 other examples. So.
Yeah, well, Luke's good enough at math that I mean, he's
think
probably
mine
right.
All right. That's it for today. I know that's a lot. On Monday, we are going to be throwing in numbers. I'll be throwing in the deep end a little bit here. Again, if you're going to be at some point quarantined in the near future, at some point, if you are, I'll still Zoom every day. I'm going to still post videos. This weekend will be a massive update to the website because I need to post a ton of videos. I've been kind of lax on it. So there's going to be a ton of things going on this weekend. So kind of ignore it for a little while. If you need it, you can go back and watch it. We have homework. That worksheet I gave you, this one, the continued worksheet. It's due on Tuesday. Some of you have already turned it in because I gave it to you yesterday. But make sure you get the signed one turned in first.
These are a different
Is Zoom mandatory?
Or can you play